Section 15b6 addresses single insulated conductors. Single insulated conductors should not be grouped together in a common enclosure in such a manner as to form a conductor bundle. This means you cannot take multiple single insulated conductors and run them through a single clamp or fitting in a way that creates a bundle. The National Electrical Code, or NEC, provides guidelines for safe electrical installations, and these guidelines often specify the maximum number of conductors allowed in a particular conduit, raceway, or clamp. The purpose of these limitations is to prevent overheating of the conductors due to the accumulation of heat generated by the current flowing through them. When multiple conductors are bundled together, the heat they generate cannot dissipate effectively, which can lead to insulation breakdown, short circuits, and potentially fires. The NEC provides tables and calculations to determine the allowable ampacity of conductors based on factors such as conductor size, insulation type, and the number of conductors in a raceway or cable. These ampacity tables take into account the directing factors that must be applied when multiple conductors are present. Directing factors reduce the allowable ampacity of the conductors to compensate for the increased heat generated by the bundled conductors. When installing electrical wiring, it is crucial to consult the latest edition of the NEC and any applicable local codes or regulations. These codes provide detailed requirements for conductor sizing, overcurrent protection, grounding, and other aspects of electrical installations. By following these codes, you can ensure that your electrical work is safe, reliable, and compliant with industry standards. The specific section of the NEC relevant to the situation you described likely addresses the allowable fill for cable clamps or connectors used with non-metallic sheathed cable, commonly known as Romex. While I cannot provide the exact section number from the 99 NEC without consulting that specific edition, the general principle remains the same. The NEC aims to prevent overcrowding of conductors in any enclosure or fitting to avoid overheating and potential hazards. To determine the correct number of Romex cables or conductors allowed in a single clamp, you should consult the product listing or instructions provided by the clamp manufacturer. The manufacturer's documentation will specify the maximum number and size of cables that can be safely installed in the clamp. Additionally, the NEC may have specific requirements for the installation of non-metallic sheathed cable, including limitations on the number of cables that can be supported by a single clamp or staple. These requirements are intended to ensure that the cables are properly secured and protected from physical damage. When installing Romex cable, it is essential to use the correct size and type of clamp or connector for the cable being used. The clamp should be securely fastened to the enclosure or support structure to prevent the cable from being pulled or damaged. Over-tightening the clamp can also damage the cable insulation, so it is important to follow the manufacturer's instructions for proper installation. In general, it is always best to err on the side of caution and avoid overcrowding conductors in any enclosure or fitting. If you are unsure about the correct number of conductors or cables allowed in a particular situation, consult with a qualified electrician or electrical inspector. They can provide guidance based on the specific requirements of the NEC and any local codes or regulations. Remember that electrical work can be dangerous, and it is always best to seek professional help if you are not comfortable or knowledgeable about the task at hand. By following safe wiring practices and adhering to the NEC, you can help ensure the safety and reliability of your electrical system. It is important to also understand the purpose of the non-metallic sheathed cable, or NM cable, which is a type of electrical wiring commonly used in residential buildings. It consists of two or more insulated conductors enclosed within a non-metallic sheath. The sheath provides protection for the conductors and helps to prevent them from being damaged or exposed to moisture. NM cable is typically used for branch circuits that supply power to lighting, receptacles, and other electrical devices. It is available in various sizes and configurations, depending on the current carrying capacity required for the circuit. The size of the conductors in the cable is determined by the ampacity, which is the maximum amount of current that the conductors can safely carry. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. When installing NM cable, it is important to follow the NEC guidelines for proper installation. This includes ensuring that the cable is adequately supported and protected from physical damage, and that it is not exposed to excessive heat or moisture. The cable should also be properly secured to boxes, fittings, and other electrical equipment. One common mistake that people make when working with NM cable is over-tightening the cable clamps or connectors. This can damage the cable insulation and create a potential fire hazard. It is important to use the correct size and type of clamp or connector for the cable being used and to follow the manufacturer's instructions for proper installation. Another important consideration when working with NM cable is the grounding of the electrical system. The NEC requires that all electrical systems be properly grounded to provide a safe path for fault current to flow back to the source. This helps to protect people from electric shock and to prevent damage to electrical equipment. The grounding conductor in NM cable is typically a bare copper wire that is connected to the grounding busbar in the electrical panel. The grounding conductor should be properly sized and installed according to the NEC requirements. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It is important to check with your local building department to determine the specific requirements for your area. By following the NEC and local codes, you can ensure that your electrical work is safe, reliable, and compliant with industry standards. When dealing with electrical installations, several key considerations must be taken into account to ensure safety and compliance with the National Electrical Code. Firstly, conductor ampacity is crucial. The ampacity of a conductor refers to the maximum amount of electrical current, measured in amps, that it can safely carry without exceeding its temperature rating. The NEC provides tables, such as Table 310.15b16, that list the allowable ampacities for various conductor sizes and insulation types under specific conditions. Factors such as the ambient temperature and the number of current-carrying conductors in a raceway or cable assembly can affect the ampacity of a conductor. Therefore, it's essential to apply the appropriate dating factors as specified in NEC section 310.15c to ensure that the conductor's ampacity is not exceeded. Secondly, overcurrent protection is paramount. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits and equipment from excessive current flow that could result in overheating, insulation damage, or even fires. The NEC requires that overcurrent protection devices be selected and installed according to the ampacity of the conductors they are protecting. NEC section 240.4 provides guidance on the proper selection of overcurrent protection devices for different types of conductors and applications. Thirdly, grounding and bonding are vital for safety. Grounding refers to the intentional connection of electrical circuits and equipment to the earth, providing a low impedance path for fault currents to flow back to the source. Bonding, on the other hand, involves connecting metallic parts of an electrical system together to create an electrically conductive path. Grounding and bonding help to minimize the risk of electric shock and ensure the proper operation of overcurrent protection devices. NEC Article 250 contains detailed requirements for grounding and bonding electrical systems. Fourthly, wiring methods and materials must adhere to standards. The NEC specifies acceptable wiring methods and materials for different types of electrical installations. These include rigid metal conduit, electrical metallic tubing, non-metallic conduit, cable trays, and various types of cables such as NM cable or Romex, mentioned earlier. The choice of wiring method depends on factors such as the environment, the type of occupancy, and the mechanical protection required. NEC Chapter 3 provides detailed information on wiring methods and materials. Fifthly, equipment listing and labeling are important for verification. Electrical equipment, such as panels, switches, receptacles, and lighting fixtures must be listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all. Listing and labeling indicate that the equipment has been tested and found to comply with applicable safety standards. The NEC requires that listed and labeled equipment be installed and used in accordance with the manufacturer's instructions. Sixthly, working space and access should be considered. The NEC requires that sufficient working space be provided around electrical equipment to allow for safe operation and maintenance. NEC Section 110.26 specifies the minimum dimensions of working space based on the voltage of the equipment and the location of any obstructions. Additionally, the NEC requires that access be provided to electrical equipment for inspection, maintenance, and repair. Seventhly, box fill calculations are necessary to prevent hazardous situations. The electrical boxes are used to enclose wire connections and protect them from physical damage. The NEC limits the number of conductors, devices, and fittings that can be installed in an electrical box to prevent overcrowding and ensure proper heat dissipation. NEC Section 314.16 provides rules for calculating the allowable fill for different types of electrical boxes. Eighthly, conductor identification is important during installation and maintenance. Conductors must be properly identified to ensure that they are connected to the correct terminals and that the electrical system is wired correctly. The NEC requires that conductors be identified by color coding, marking tape, or other approved means. NEC Section 310.110 provides requirements for conductor identification. Ninthly, protection from physical damage is crucial, especially where it could damage the wiring, such as low-hanging trees. Electrical wiring and equipment must be protected from physical damage to prevent insulation breakdown, short circuits, and other hazards. The NEC requires that wiring be installed in raceways, cable trays, or other protective enclosures where it is subject to physical damage. Additionally, the NEC requires that equipment be located or protected to prevent damage from impact, abrasion, or other causes. Tenthly, compliance with local codes and regulations is mandatory. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations that must be followed. These codes may be more stringent than the NEC in some areas. It is important to check with your local building department to determine the specific requirements for your area. Firstly, let's address conductor fill limits. Electrical codes, such as the NEC, specify the maximum number of conductors allowed in a conduit, raceway, or cable assembly. These limits are in place to prevent overcrowding, which can lead to overheating and insulation damage. The allowable fill depends on several factors, including the size of the conduit or raceway, the size and type of conductors, and any dirting factors that may apply. Secondly, conduit and raceway types play an important role. Different types of conduits and raceways have different fill capacities. For example, rigid metal conduit, or RMC, typically has a higher fill capacity than electrical metallic tubing, or EMT. Non-metallic conduits, such as PVC, also have their own fill limits. The NEC provides tables that list the allowable fill for various types of conduits and raceways. Thirdly, conductor size and insulation matter as well. The size of the conductors also affects the allowable fill. Larger conductors take up more space, so fewer of them can be installed in a given conduit or raceway. The type of insulation on the conductors also matters. Some types of insulation are thicker than others, which can reduce the allowable fill. Fourthly, dirting factors can change the requirements. Dirting factors are used to reduce the allowable ampacity of conductors when they are installed in close proximity to each other or in high-temperature environments. When dirting factors apply, the allowable fill may need to be reduced to compensate for the increased heat generated by the conductors. Fifthly, box fill calculations are necessary. Electrical boxes are used to enclose wire connections and protect them from physical damage. The NEC limits the number of conductors, devices, and fittings that can be installed in an electrical box to prevent overcrowding. Box fill calculations are used to determine the allowable number of conductors in a box based on its size and shape. Sixthly, cable fill limits are also important. Cables such as NM cable or Romex also have fill limits. The NEC specifies the maximum number of cables that can be installed in a given cable clamp or connector. Overfilling cable clamps can damage the cable insulation and create a fire hazard. Seventhly, support and securement must be considered. Conduits, raceways, and cables must be properly supported and secured to prevent them from sagging or becoming damaged. The NEC specifies the maximum spacing between supports for various types of conduits, raceways, and cables. Eighthly, bending radius can also affect your requirements. Conduits and raceways must be bent with a minimum radius to prevent damage to the conductors inside. The NEC specifies the minimum bending radius for various types of conduits and raceways. Ninthly, expansion and contraction can change the situation. Conduits and raceways can expand and contract due to changes in temperature. The NEC requires that expansion fittings be installed in long runs of conduit or raceway to accommodate this expansion and contraction. Tenthly, sealing and fire stopping can add complexity. Conduits and raceways that pass through fire-rated walls or floors must be sealed to prevent the spread of fire and smoke. The NEC specifies the requirements for sealing conduits and raceways of fire-rated construction. Firstly, consider the National Electrical Code NEC, which sets standards. The NEC, published by the National Fire Protection Association, or NFPA, is the primary standard for electrical installations in the United States. It provides comprehensive guidelines for the safe and proper installation of electrical wiring and equipment. Secondly, remember local amendments can vary. Local jurisdictions may adopt and amend the NEC to suit their specific needs and requirements. These local amendments can be more stringent than the NEC in some cases, so it is important to be aware of them. Thirdly, licensing and permits must be considered. Most jurisdictions require electricians to be licensed and to obtain permits for electrical work. Licensing ensures that electricians have the necessary training and experience to perform electrical work safely. Permits allow local authorities to inspect electrical work and ensure that it complies with the NEC and local codes. Fourthly, inspections are required during the process. Electrical inspections are typically required at various stages of an electrical project. These inspections are performed by local electrical inspectors to ensure that the work complies with the NEC and local codes. Fifthly, documentation is critical for all projects. Proper documentation is essential for electrical projects. This includes detailed plans, specifications, and calculations. Documentation helps to ensure that the project is properly designed and installed, and it provides a record of the work that was performed. Sixthly, safety is paramount always. Electrical work can be dangerous, so safety should always be the top priority. Electricians should wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and footwear. They should also follow safe work practices, such as de-energizing circuits before working on them. Seventhly, training is essential to keep abreast of changes. Ongoing training is essential for electricians to stay up to date on the latest codes, standards, and technologies. Training can help electricians improve their skills and knowledge, and it can also help them to avoid making costly mistakes. Eighthly, continuing education is important for growth. Many jurisdictions require electricians to complete continuing education courses to maintain their licenses. Continuing education helps electricians stay current on the latest changes to the NEC and local codes, and it can also help them to learn about new technologies and techniques. Ninthly, professional organizations can help your career. Professional organizations such as the Independent Electrical Contractors, or IC, and the National Electrical Contractors Association, or NEC, provide resources and support for electricians. These organizations offer training, networking opportunities, and advocacy for the electrical industry. Tenthly, insurance is important for safety and liability. Electricians should carry adequate insurance coverage to protect themselves and their businesses from liability. Insurance can help to cover the cost of accidents, injuries, and property damage.